Hello, this is Mr. Kenyanola, and today I'm going to teach you about rotations. So in this video, you'll get the definition of a rotation, two different ways to rotate an object, and three examples that you would see in your math class on how to rotate an object on the coordinate plane. So, what is a rotation? So a rotation is one of the four different types of transformations. So depending on where you're at in your class, the four different types of transformations are translations. So a translation is, so here's a key. A translation is moving an object. So on the coordinate plane, on a plane, so left, right, up, down, diagonally. Okay, a reflection. So the other type of transformation is a reflection. So a reflection would be taking this key and flipping it over a line of symmetry. So like this or like this. The other type of transformation is a dilation. Dilation is making something appear bigger or smaller. And this is a rotation. So a rotation is taking an object like this key, and we have a circle. Actually, we have two circles. So earlier in the video, you saw the record player. So you can think about a rotation. An example of a rotation is a record player spinning or rotating around a center like this. So here's the center of this outer circle. And what the record player does is it spins the vinyl or the record so that it rotates. So but here, instead of spinning the circle, this key would rotate around this point right here. So think about this. A circle has a radius, so it's this far away from the center, and this key is going to stay that same distance away, so that the radius distance away, and it's going to just circle around that center. So here's that. So there's that. And if you notice, as it circles around, okay, look at the top of this key. As it circles around, it also rotates accordingly. Right? So if this was a car going around in a circle, the front of the car is still at the front as it's traveling around the circle. So if it traveled like this, okay, and the front, okay, still stayed at the top, okay, that would not be a rotation, that would be a translation, okay? So as we rotate, the orientation of the key actually changes as it goes around, okay? So we could still rotate it around this point from another distance, so using a different radius. So if we went from here to here, put the key there. Okay, so, and we said, okay, we want to rotate it around this. So, again, okay, it still rotates around this same center, but it's just, it starts off closer, to the center. So there's that. So, remember, as the object rotates around the center, the front also rotates accordingly. Okay, so if its orientation didn't change, if it stayed static like this, if it still stayed pointing up, that wouldn't be a rotation, that would be a translation. Okay, so in the opening slide, if you saw the preview, okay, so how this little boy is rotating, okay, so his leg starts going upside down, he's doing a flip. Okay, so that would be a rotation. If he stayed this way and his feet were still below him, then that would not be a rotation. So here's our first example of a rotation. So let's read the instructions. It says, a rotation of 90 degrees counterclockwise about the origin. So let's try to predict where this eye, if we rotate it 90 degrees clockwise about the origin, would end up. So let's try to remember from Algebra 1, with a coordinate plane, there are four quadrants. Here's our first quadrant. Here is our second quadrant, third quadrant, and fourth quadrant. And it says rotate it counterclockwise. So think about a clock. Okay, most of us have digital clocks now, but or digital watches, but the older clocks in your classroom, clockwise would go this way, so rotation would go this way, clockwise, but it's asking counterclockwise, so counter to that would be the other direction. So, and if we went all the way around in a full circle, that would be 360 degrees, but it says rotate it only 90 degrees clockwise. So if we divided up these 4 quadrants, so let's put a little square here. So this represents 90 degrees, 90 degrees, another 90 degrees, and another 90 degrees. So this, each of these quadrants represents 90 degrees for the full 360 degrees. So if it says, okay, so here's our eye, and we want to rotate it counterclockwise 90 degrees this way. So where can we predict it would end up? Yeah, it would end up somewhere around the second quadrant, because this is just the first 90 degrees. So I told you I'd show you 2 ways to get to the correct answer. So what we do is, our first method of rotating eye 90 degrees clockwise is we would take some tracing paper. So here's some tracing paper, you know, tracing paper because you can see right through it, or some patty paper. So some kind of transparent paper, and you would put it right on top of this. And what you're going to do is, you're going to take your pen or pencil, and here's the origin right here. Okay, so what I'm going to do is I'm going to draw a little plus sign, because this is going to help us assure that we rotate it exactly 90 degrees. So here's our little plus sign, and then what I'm going to do is I'm going to take, oh, before I do that, let's mark our eye. So here's our point, I, so it's there. And we want to rotate this tracing paper 90 degrees counterclockwise. So what I'm going to do is I'm going to take my pen, I'm going to put it right here on the origin, because we want to rotate around the origin. And then I'm going to take my piece of paper. Okay, so see how it rotates? Okay, and this still stays there. And see how the plus sign rotates. So I'm going to rotate it 90 degrees so that the plus sign, okay, until the plus sign is aligned, okay, with what's right under it. And there's a little toy right there. I'll move it around. So again, I'm going to take my pen, so to anchor it, okay, so that the plus sign still stays right there on top of the origin. And I'm going to rotate the paper 90 degrees until this plus sign is aligned again with the X and Y axis. And we know that that point is going to be on somewhere in the second quadrant. And it's right there. So I'm going to take a pen, lift this up, and mark it off right there. So that's where our new I would be, I prime, okay, at that point. So what I did was I put a little plus sign, okay, so just so I know that I have the 490 degrees right there, okay, and this plus sign is aligned with the X and Y axis. I marked the point I right there, the point that I want to rotate around the origin, put my pen on the origin so that when I rotate this tracing paper, the paper still stays anchored to the origin. And then keep your eye on the plus sign down there so that I'm going to keep on rotating until it aligns up with the origin, the X and Y axis again. Just one time, because we know it's only 90 degrees and would end up in the second quadrant. And there it is. It's all lined up. There is that. And I would just mark off that point, I prime. So let's figure out what the coordinates of this. So original I was at 2, 1, 2, 3, 4. And our new rotated coordinates would be at -1, -2, -3, -4, up, 2. So there is our answer, -4, 2. So I told you I'm going to show you a different method of doing this. So the first method is if you have transparent paper, tracing paper, then that's great. You could do that. But let's say you don't have tracing paper. You just have a pen and you have your problem. That's fine. You don't have a problem because you can still get the correct answer. What you would do is you would get the coordinates. So this is 2, 4. Mark off the first axis, second axis, third axis, and fourth axis. So instead of actually rotating the point like we did, so we rotated the point, okay, this way, just like the record player earlier in the video, instead of rotating the needle around the record, we're just going to rotate the record. So I'm going to rotate this, put my pen here, and rotate it 90 degrees this way, okay? So that this is my new first quadrant, second quadrant, third quadrant, and fourth quadrant. So, and this would be my new x-axis and my new y-axis. Okay, so we rotated the entire coordinate plane instead of just rotating the points. Okay, so rotate the entire coordinate plane, and then I'm going to mark the new 2, 4. So this is, remember, this is our new x-axis and this is our new y-axis, and we just rotated the entire piece of paper 90 degrees, so that now the first quadrant has rotated 90 degrees here, second quadrant, third quadrant, and fourth quadrant. I'm going to mark, okay, 2, 4 with this new rotated coordinate plane. So here is 1, 2, and then go up 4, 1, 2, 3, 4. And I'm going to mark this as I prime, but I'm going to write it this way. The reason why I'm going to write it this way is to get our final answer. So is we're going to rotate it back to the original orientation. Here's what that 2, 4 when we rotate it, but now we rotate it back, and let's figure out what the coordinates are. So -1, 2, 3, 4, and up 2. Hey, and look at that. We got the exact same answer. So here's a little review of this method. You figure out the coordinates of the original, and then you just rotate it however many degrees it tells you. So rotate it 90 degrees. So I'm rotate it 90 degrees, making this the new x-axis and this the new y-axis, and plot the original points with a new x and y-axis. So 2, 4. But don't say the answer is 2, 4 until you rotate it back to the original orientation, and then look at those coordinates, -4, 2. So there's your second method. If you don't have patty paper or tracing paper, this method always works. Okay, so here is the second example. So rotate about the origin, 180 degrees about the origin. So let's mark up first quadrant, second quadrant, third quadrant, and fourth quadrant. And we want to rotate this G. Don't mind this little point right here. This is just the marker bleeding through from the previous problem. So here's G, and we want to rotate it 180 degrees. It doesn't say clockwise or counterclockwise, because with 180 degrees, it really doesn't matter. If we rotate this 180 degrees counterclockwise, we will go 90, and 180, we would end up in the second quadrant. If we went clockwise, 90 to 180, we would still end up in the same quadrant, so second quadrant. So that's why if you ever see problems that say rotate 180 degrees, it really doesn't matter where you rotate it, which way, clockwise or counterclockwise. So let's get our original. So let's do the first way of doing this. We're going to take our tracing paper. Okay, and we're going to mark point G. So this is the same trace paper. I don't want to waste paper for you guys are going to say, oh, stop killing trees. So we're going to use the same piece of paper. Ignore this point, and we're going to mark G with our red pen. So there's G. And then let's rotate it 180 degrees. I'm going to go counterclockwise. So watch the plus sign. So there's 90 degrees as the plus sign aligns up with the X and Y axis. And then we'll go 180 degrees, another 90 degrees. So there. So G would end up at this point right here. Gonna lift it up. And there is our G prime. Okay. And well, let's do this. Let's go back. Let's rotate it back. And just so you guys believe me, let's rotate the tracing paper clockwise. So here is 90 degrees. Okay, and then here's another 90 degrees to make the full 180 degrees. And look at that. It ends up being in the same spot, G prime. All right, and if you want to know the other method, let me quickly do it for you. So here's G. The coordinates for G are 1, 2, 3, 4. 1, 2, 3, negative 4. So the coordinates of G would be 4, negative 4. And we want to rotate this 180 degrees. So I'm going to take a different colored pen. And I'm going to rotate this. So here's a 90-degree rotation of the piece of paper. And then here is a 180-degree rotation of this piece of paper. And this would be our new first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, first quadrant is always in this section right here, the upper right-hand side. And we want to plot 4, negative 4. So 1, 2, 3, 4, and then go down, negative 1, negative 2, negative 3, negative 4. And as you can see, it lands in that same spot where we use the tracing paper and rotate it back. It's that exact same spot. All right, so, and here is our final example, a rotation of 270 degrees counterclockwise about the origin. So here's our first, second, third, and fourth quadrants, and about the origin. So this triangle is in the third quadrant and go counterclockwise. So here's a 90, 180, and 270 degrees. So 270 degrees, it would end up somewhere around here in the fourth quadrant. So let's take our tracing paper. I'm going to use that same tracing paper. And so you guys, again, don't accuse me of killing trees. And I'm going to take a different colored pen. And let's mark G, points G, H, and F. So here's G, here's H, and here is F. And let's write G, H, and F. And we want to rotate this 270 degrees counterclockwise. So remember, we're going, oh, actually, did I say? So counterclockwise would go this way. So I think I misspoke. Counterclockwise would be 90, 180, 270 degrees. So it would actually end up in the second quadrant. Okay, so let's take our pen and rotate it 90 degrees. So that would be 90. We're going counterclockwise. So this would be 180. And this one would be 270 degrees counterclockwise, the opposite way that the clock moves. And let's lift up our tracing paper. And this looks like this is point F. Here's point H over here. And here's point G, just right there. And let's take a straight edge straight edge is just something with an edge that's straight. And connect those points. There, and there. And there is your rotation. So, notice that F is now pointing this way. G is now pointing this way. H is pointing downwards because it rotated. And the rotations, yeah, the object rotates. So that's how you rotate. If you want to do the other method, try it. So if you have tracing paper, then do the tracing paper method way. If you don't have tracing paper, then use the method of rotating the piece of paper with a new quadrants and then rotating it back and getting those coordinates. All right, hope that helps. That's rotations. Have a great day.